Okay, so today we are going to talk about parabolas. And we're going to talk about a definition of a parabola that you've probably never heard of. You know, in general, that a parabola looks like this. And this is a parabolic function. That's not a great drawing, but roughly that shape. Okay, so we're going to talk about what the definition of it actually means. It's not just a quadratic function. Okay, and hopefully somewhere along the line, you've learned the definition of a circle. And a circle is a set of points equal distance from a single point, implying that every point on the circle has the same radius r. Okay, so that definition is a set of points equal distance from a single point. And we are going to use this definition or similar definitions to define what we call conic sections. And they're all made by cutting a cone. Okay. I'll try to show a 3D in class of what the cones look like. But there's four kind of conic sections. One of them's the circle. One of them's the parabola, and I'll show you how you get that by cutting a cone. There's some illustrations that I can show you. One of them is a ellipse, which is like an oval. And I think we talked about ellipses in Algebra 2. And one of them's a hyperbola, which you don't know. Sort of parabola-like shape, but not exactly. So the definition of a parabola is a figure, doesn't need a graph, equal distance, a set of points that are equal distance from a single point, known as the focus, and a line known as the directrix. Now, when you measure to a line, you must measure perpendicular. Pretend my drawing's good and those are the same length. And here the vertex is going to be equal distance here. And then this is true for every point. Yeah, my drawing's not the best. That they are equal distance, not drawn to scale. So let's talk quickly about graphing a circle. I know, let's talk about the parabola. The circle you should already know, and just to remind you, x minus h squared plus y minus k squared, we've done this already this year, equals r squared. Hk being the center, radius being r. The parabola, this general format, looks a lot like vertex form. So vertex is hk, you're used to that. This difference here is 1 over 4p. P, or sometimes you'll see it as c. P is distance from focus or directrix to vertex. Big distance. Say focus to vertex or directrix to vertex because they have to be equal. So we are going to talk about making a parabola. This one's nice. It's kind of wide. It's got a focus here at 2, which means it has a directrix at -2. Vertex is 0, 0, so h and k are 0, 0. So I know that p equals 2. My equation becomes y equals 1 over 4 times 2 is 8. H and k are are 0, so 1/8 x squared. What if the vertex is the origin? And let's put another one. I'm going to put it on the same graph. It's opening down. But this time, the focus is -3, 0, which makes the directrix y equals 3. Again, plug in 3. This distance here is 3. 1/4 times 3 is 1/12. It opens down, so I know it's that -1/12 x squared. It's the negative because it opens down. Okay. Now we're about to do some that are not functions. Let's go to a note page. No, I'll leave it there. So these are going to be ones that open sideways. So K is the Y transformation, so it goes with. So I am basically changing these. What do? I switch X and Y, and that makes the parabola open sideways. It's essentially doing an inverse, and this time I'm allowed to have an inverse that's not a function. So here I have, what is the equation for a parabola with vertex at the origin and directrix? X equals 1.25. That's a vertical line. So vertex is at the origin. X equals 1.25. That tells me, I'm looking at this original one here, tells me it's got to open this way. The focus has to be over here. Focus is always inside. And P is equal to the 1.25. I know the directrix or the focus's distance. That's 1.25. That's P. I know this is a sideways one. So it's going to be an X equals. It's going that way, which says it's negative. 1/4 times 1.25. And again, H and K are 0. They're nice about that. So -1/5 y squared. Okay. What if they give me an equation and ask me, where is the focus and directrix? Okay. So I know this one, again, it's a sideways one, centered at 0, 0. It's opening in the positive direction, so focus is going to be inside, and directrix will be somewhere outside. And the distance is P. I intentionally haven't labeled those because I don't know how far. But 3/4 is in the place where the 1/4P usually goes. So I can just set them equal and solve. So I'll cross multiply here. 3 times 4P equals 4P, or 4. Divide by 3 times 4. Yes, I could make that 12, but I've noticed that I've got a 4 in both of them, so I'm just going to leave the 4 because that's going to cancel. I don't know why I put it out there, like I was multiplying it by something. Okay, so my 4's cancel. 4's cancel here, 3's cancel there. I'm left with P equals 1/3. So my focus is 1/3. And I should list this as a point, not as an X equals, because that is a point. And my directrix, I know my directrix is in the outside, so it's negative. X equals -1/3. Okay. We can also solve word problems. Okay. So a three-dimensional parabola, there's an interesting property of a parabola. If I have a parabola, anything coming in, here's the focus. Anything coming in vertically that hits the parabola will be reflected to the focus. All of these, which is why what you use they're used a lot for mirrors sometimes for old solar panels. That's what they show in the example in the book I have. A three-dimensional paraboloid would be a satellite dish, and they focus beams coming straight down from outer space to a single point, the receiver, the of a paraboloid. Paraboloid is a three-dimensional one. So the parabolic solar reflector pictured has a depth of 2 feet at the center. How far from the vertex is the focus? What is the focal length? So I know it's got a depth of 2 feet, and they've got a picture. It looks kind of like this. And somewhere, and then it's got a receiver kind of in the middle. Wants to know where the focus is. So this is 2, and it's got a width of 8. There. So I'm going to put that on a graph. I'll put the vertex at 0, 0, because that's easy. And I've got 2 other points here. 4, 2, negative 4, 2. Okay. So we got that. That's going for us. That's pretty good. We know h and k are 0. So I'm looking at a y equals ax squared, right? So 2 equals a times 4 squared. 4 squared is 16, so I'll divide by 16. I'm solving for a here. A equals 1/8. So A is supposed to be 1 over 4p. Now I can just go ahead right now and see that 8 is, the p is 2. But I can multiply both sides by 8 and by p. I could just kind of cross multiply here. Why don't I cross multiply? It's probably easier for most of you. 8 times 1 is 8. 4p, divide by 4, and I get 2 equals p. So the focus is 2 feet above the satellite dish. It's right on the outside edge. Not shocking. Kind of a common way to do it. Last thing we're going to do is take a standard form equation and find the focus in Directrix. So first thing I do want to do is find the vertex. Easiest way to remember, negative b over 2a is going to give me my x coordinate. X equals 4, positive 4 over 2 times 1. The x coordinate is 2. And then I'm going to plug it in to get the y coordinate. So when I plug it in, I get 2 squared minus 4 times 2. That's 4 minus 8 plus 8, so 4. So this is my vertex. I'm going to put it in vertex form. I'm looking at A being 1. So remember vertex form, ax minus h squared plus k. So that's A is 1. x minus 2 is the h plus 4. So 1 over 4p is my a, which is 1. That means p is 1/4. I can multiply both sides by p and I get 1 over 4 equals p. Multiply both sides here by p. It out. And so now I want the focus and directrix. I've got the vertex. The focus means I go up 1/4. So same x coordinate. This one's opening in this one I know basically it looks something like this. I don't care on how wide really. Looks like that, so it's normal up. And that'd be 4 plus 1/4 is 4.25. Or if you want to be awesome, you're going to write it as an improper fraction. That's 17/4. The directrix, remember, is a line just underneath it by 1/4. So I'm going to take 4 and I'm going to subtract 1/4. It's 3.75. Or again, if you want to be really awesome, 15/4. Okay, that is your focus and directrix of parabolas and the definition of a parabola.